Bringing what we just saw back to our notes here, let's go ahead and talk through another way to consider this binary octal conversion. When we have our numerical values understood, this will be a powerful tool for you. Let's think about the digits that we have that comprise a set of permissions, R, W, and X. When using the numeric method, we'll need to represent each of these with a value in octal. In the 3-digit octal numeric representation for permissions, each of the digits we'll create stands for one access level: user, group, and other. In order to determine the digits, here's an easier explanation on how to do the math. Step 1 has us starting with 0. We'll then take the permissions for one of the groupings. In this case, we would start with user. If the user had the read permission, in other words, if read is enabled for the user, then we'll add 4. If the write permission is enabled, we'll add 2 more. And if the execute permission is enabled, we'll add 1. This gives you a total of 0 through 7 as options for the user access permissions. For example, if we were given this particular string of permissions, we can see that just the first 3, RWX, are available for the user. This means that a 4 for read, a 2 for write, and a 1 for execute would all be enabled, and therefore all adding up to 7. Our octal representation for the user permissions is 7. The next digits that correspond to the group permissions are R-X. R-X would be a +4 for the read permission, +0 since we don't have the write permission, and +1 for the execute permission, or 5 in total. Our group permission octal value would be 5. Lastly, since other has 0 permissions, we don't have to add anything, and the value would be 0. Putting these 3 numbers together, we realize that the permission structure RWX R-X -- corresponds to the octal value 750. Once we know how to calculate these, we can then use the chmod command to change the mode bits in this same fashion. Here you can see an example of using the change mode command along with the octal representation of the permissions we wish to set. Here you can see an example command using chmod to change the mode bits and an octal representation for the permissions they wish to set. RWX each corresponds to 4, 2, and 1. So we can determine that a 6 means that we wish to have the read and write bits for user. The 4 means that we have the write bits for the group user, for the group ownership and members. And the last 4 means that we have the write permission for all others. Another way to express this would be to say -RW, then we would not have the read permission, we would have the write permission, and we would not have execute. And the same would be true for other. In this next example, we see the user set up with 750. We saw this in our previous example exactly, but let's go ahead and write out what this would look like. If we had the user set up with 7 as its permission, that's all 3, read, write, and execute. A 5 is a 4 and a 1, so that is not read, but does have a write, worth 4, and an execute, worth 1. Lastly, a 0 means no permissions to other. With practice, you'll be able to do these octal conversions in your head, and it'll make more sense. If you find it easier, you can always rely on the symbolic representation using UGOA, the plus, minus, and equal sign, and then the permission letters R, W, and X.